Welcome to springlib.
So here we need to find the angular speed of the cylinder and then linear speed of the rope. So we should say GPE equals mgycm, where ycm is vertical distance of object's center of mass. We know that the rotational kinetic energy initially plus the translational kinetic energy initially plus the gravitational potential energy equals the rotational kinetic energy final plus the translational kinetic energy final. And we can substitute. So we have half I omega squared plus, we'll say I omega initial squared plus half mv initial squared plus mgycm. This is going to be equal to half I omega final squared plus half mv final squared. And we know that the center of mass for this is going to be L over 2, or simply the length of the rope over 2. And this is going to be 2 pi r, or the circumference of the cylinder, divided by 2. And we know that dy equals cm equals pi r. So we can use this in order to solve for this. We can use this in order to substitute for the y of the center of mass. So at this point, we can say, okay, 1 over 2 and be careful when you're substituting because there's so much algebraic manipulation. It's very easy to get lost or confused as to what exactly you're writing down. So just make sure that you are diligently plugging in your variables. And on the other side, we have half m r squared omega final squared plus half m r squared omega final squared. So at this point, we can say, okay, this is going to be capital M. We can say, okay, let's try to solve for omega final. So we can say that m plus m over 4 plus small m over 2 times r squared omega initial squared plus mg pi r equals, and then it'll be m over 4 plus m over 2 r squared omega final squared. And we find that omega final is going to be equal to omega initial squared plus 4 pi mg all divided by r times m plus 2m all to the half power. And then because we know that v equals r omega f, that means that this is going to be r omega initial squared plus 4 pi mg all over r m plus 2m to the half power. So these would be your answers, and that's the end of the solution. Thank you for watching.